Hello, hi, and welcome to today's video in which we're going to look at a little bit PID controls or general control structures, and we're having different types of outputs. There is analog outputs and there's just digital outputs. So as example, I've got this little NIO list here, and I have in the background, you can see that here, two tank systems. They are a little bit different in that sense that the left one here has a PLC output that is connected to an analog output. So an analog output, meaning if I have this here, if I have my TIA portal and it is connected to output word 100, we can see this here. If I now set my output word 100 to a specific value, let's take 1000. If I set that to this value, right, and now I run it, you see the pump turns on and there's a little liquid stream. You can see that little blue stream of liquid going out of the valve on top there. If I set to 5000, for example, it is more liquid that's going into the tank. If I put it to 20,000, that's even more, right? Of course, there is a maximum. There's this 100% maximum. I forgot the number, 27,600 something, where the maximum is, and that's the maximum we have. But everything in between, 150, is that still visible? Everything in between, oh yeah, that's very, very small. There's a very little stream of water coming out there. So that's an analog output. I've made a video about how to control analog outputs with PIDs. It's in my PID playlist. You can find it on my channel. But there's another type of output. There's the second tank that I have here, and you see the PLC output here just says false. It just says false. And my second tank here, let's do this. Yep, my second tank here is just connected to a digital valve that I can turn on and turn off. If I set this to true, turn on. You see it turns on. If I set it to false, it's completely off. And that's either 0% or 100%. Nothing in between. Nothing in between. But that's what you have a lot of times. In industry, that's what you are faced with a lot of times. Either this solution where you have something turning on and off completely, or this solution where you have an analog output and everything in between is possible. You see the tank still slowly fills up here. You see the PLC input, tank still slowly fills up. This slowly filling up. Right now, this one here is open by a certain percentage. Like this is maybe 1% of the maximum level. If I want to achieve 1% here, right? If I want to achieve 1% of the maximum flow, there's only one way of doing that. I have to turn it on for a very short time, right? On, and off for a very long time, right? Let's say we want to turn it on 10% of the time. That means let's say with the total cycle time, there's a total cycle time. Total cycle time here will be 10 seconds, right? In 10 seconds, I want it 10% on, 90% off. That means 1 second on, 9 seconds off. That is in total 10% of the maximum flow. So rather than having it open by 10%, which is here approximately 2,500, so that's 10% flow that we can control permanently. Here we have to really go, then 1 second it is on, 9 seconds it is off. So exactly like this. So 1 second on, 1, and 9 seconds off. 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1 second on. 1. And 9 seconds off. 2, 3, 4, 5, 6, 7, 8, 9. 1 second on. 9 seconds off. We have to do that. This is what I just did. 10 seconds in total. 10 seconds total. 1 second on. And 9 seconds off. This is called pulse width modulation, PWM. We can control the output. How long is it on? If I want this 50% on in 10 seconds, what do I do? Hey, I say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, and so on. Right? So we are really doing it 50% of the time on. It is almost the same as if we have here this to 50%. 50%, that's approximately 14,000-ish. This is exactly the same, right? If I have this on, like half of the maximum width, and if I have this on, half of the maximum time, 1, 2, 3, 4, 5, off, 1, 2, 3, 4, 5, we will have exactly the same result. Well, not exactly, but almost the same result. And we can do this. We can teach the PLC to use a digital output and use PWM instead of an analog output and their an analog value. Let's set this up very quick. We'll take like 2 minutes because it's very easy in TR Portal. We have, like, I'm just putting it in main because that's possible. It's not optimal, but it is possible. Usually, if you watched my other PID videos, if you watched my other closed loop control videos, I set it up more properly and I tune the controller. I improve everything. Here it's just about, hey, what is PWM in contrast to analog value? So check out the other videos as well. I will drag in one PID compact in my main function here, and this is for tank 1, and this one is analog. I will just call it analog, could give it any name. Tank 1 analog, and I have prepared some variables. I have prepared a set point in real. A set point is in percent, right? This one is in percent. I want 50%. I could also put in liters or so, but I want 50%. So the set point goes at the set point, of course. Then I have my input and my input PER. Input could already be pre-scaled, whatever that is, doesn't matter. I want input PER, which is exactly the value I get from my tank, right? From my analog sensor. You see right now, this one here is 27,648, meaning the tank is full. This one here is right now 3,494, which means the tank is almost, or a little bit more than 10%, maybe 50% full. So those values we need as feedback, right? And for tank 1, I have prepared a sensor. And of course, for tank 2, I have prepared a sensor as well. This is my analog input sensor here. I will put that here. And I will do the same for tank 2, but let's prepare tank 1 first. And then we have here with PID compact, we have output PER, and we have output PWM. Output PER is the output for a analog output module. So what we're using for the first tank, it was this analog output module, right, on the left side. Analog output module where you can control how much water is flowing at all the time. So that's what I want. So that's what I'm also going to use for the first tank here, which is output and analog output. I will put to PER. All that's left to do now for the first tank is for the first tank with the analog output, I check the configurations with clicking on that little toolbox there. And there I see I general in percent. I could also make it here in liter, and so not gonna happen this time. I don't want to change the mode right now. I want to check the input parameters and output parameters. And there I see this controller is going to work with input PER, which is an analog value, because that's what we have as input. And it's going to work with an output PER, which is an analog output. That's the first tank. That's what we're using here. Done. Done, right? That's it. I download the program. And for the first tank, it is not going to work yet. So let's reset the room here. You see it's still off, right? We need to manually, because I did not change the mode here, I have to go into commissioning very quick. I click on start, and down here, you see it. It's enabled, but it's in manual mode. I want to stop it and I want to start it, right? And you see on top, the PLC output is right now controlled. Right now we're at 1.06 liters per second flow, right? You see the flow gets lower and lower and lower. This is because the PID controller decides, hey, we need less flow, right? We need less flow. This is controlled. And you can also see, like this thing, the little line, the little water coming out of the valve is getting thinner and thinner. Can I do this actually? Let's see how wide it is. Right now it's this. It's getting thinner, and it's getting thinner, and thinner, and thinner. And you see at some point it will be gone. This is the analog output, right? So that's controlled already. This is how you build a PID controller and PLCs. Hey, that was easy. So that was the first one. And I can, of course, see the behavior here as well. It is not perfectly tuned, so it's not good. So that's the first tank with this output analog, right? Now I want to have the same thing with this pump that just goes on and off. So I go to my instructions, I go to technology, and I put in a second PID compact here in the second network. This is for tank 2, which is digital, right? Which is digital, let's call it PWM actually. Pulse width modulation. And there we go. That's my second one. So I want to have the same set point for both tanks. So the set point goes here to the set point. The input in my second one is, of course, the analog input for my second tank. Right? So I'm still using an analog input. What I want to use is a digital output for the second tank because I do not have an analog one. So I take that digital output and put it here on this PWM output. Right? On the PWM output. In the first one, I put it on the PER, which is analog. In the second one, I put it to the PWM, which is digital. You can see one hint in TIA Portal. If you see a black line, black indicates, hey, that's digital or Boolean 0 or 1, on or off. Right? This can only be on or off. If you see an orange line, that can be a value, 0, 1, 2, 3, 4, 5, 6, 7, or here in this case, a float value. Right? So it's this one here is just on or off. That's what we have. So the last thing that we need to do is now we need to tell this PWM, this PID controller to work in PWM mode. So I open my configuration. This stays the same. I go in my input and output parameters. The input is still analog, but the output, it should use this PWM output. So I choose the PWM output. You see we made some adjustments. That's it. That's it. I now download the program. And all that's left to do, you will see it does not automatically start. That's stupid. The left one already starts. And you see the flow gets thinner and thinner. See that with the value on top. This one here does not start yet. What do we have to do? Oh, it's not set to automatic mode. Let's set that thing to automatic mode. Tank 2, commissioning, start, and stop the manual mode and start the automatic mode. So let's see what happens. You see on, off, on, off, on, off, on, off, on, off. This is now some percent. We can see how much percent that is right here. You see a value right now. It's approximately 45% on of the time. Right? You see it gets less and less and less. Right? Now it's just 33%, only 1/3 of the time it's on. And it's getting less and less. And you will see the stream of water that we see is also, it's not getting thinner, right? It's not getting thinner, but it's getting more cut off. And now it's only like 10% anymore. And you see it's only for a very short amount of time on. For a very long amount of time it's off. Now we're at 7%, 5%, only 5% on. You see it's 2%, and it will now reach 0%, but because we are already above the level that we want to get to. So let's see those two in comparison. They are doing the same thing. On the left side right now, it is on for like 80%. On the right side, it's also on for 80% of the time. The difference is, here it's bursting out, right? It's bursting out, and on the left side, it's going smaller, smaller, smaller. Percentage-wise, they're on the same time. Or they are doing the same thing. Yeah. So that's how you use the PWM output there. Pretty easy, pretty simple actually. I wonder if they will actually get to the same level. They will probably not get to the exact same level, approximately to the same level. So they're not 100% doing the same thing. They're definitely not going to 50% both. The right one is now at 36 liters. That one is at 37.36 already, and we stopped. Right. So that one was a little bit more precise. What would we need to do? Now we would need to tune. I made a video about tuning, so I could now click here on tuning. Right, there is on top. I could now click on tuning, which I won't do. That's a different video. That would be to improve our controller, which does not work because I put all the program in my main. I would need to make more things. Check out the video I made on tuning. I might make one actually here on this later on, because it's so much fun playing with those tanks. The last thing for this, in our configuration, we have Pwm limits, right? If I go to my tank 2, there's the one that uses PWM, there's Pwm limits. You see those limits right now are set to 0. 0 seconds on time and 0 seconds off time minimum. And we can also see that right now the pump is basically on off pretty fast. Now imagine you are sitting in a car and you are stepping on the pedal, right? On off, on off, on off. You go in chunks, you go in jumps, dip, dip, dip. That's probably not the best. What would be if those jumps would be not too fast, like not on off, on off, on off, on off. That's what it is right now because we have it set to 0. It's not that bad here, but imagine it's worse in a car, on off, on off, on off, on off. That's bad. I know people that drive that way. It drives me insane. No, we want this to have a minimum time. On, off, on, off, on, off. And that is the so-called minimum time. Right? I can set it here. Let's set this, for example, to 1 second, right, for both. I now changed it directly online, pretty easy. You see it's orange. I'm directly changing the value in the PLC. Now I set it to 1 second, and let's see what happens. I reset the room. And now you see this is on for even longer. You see it's very long on, and at least 1 second off, right? 1 second off and some seconds on. So the minimum time that it's now on or off is 1 second. If I put that, for example, to let's over exaggerate. Let's put it to 5. That's way too much. The least amount of time it is on is 5 seconds. The least amount of time it is off is 5 seconds. So that doesn't switch too fast. Fast switching, pretty bad. Right now it's 5 seconds on, 5 seconds off. This will of course now break everything because, well, if it's at least 5 seconds on, we will definitely go over the tank limits. But it's better for the pump itself. Yeah, we reached the limit of the tank, so that's pretty bad. I usually set it to something like a second or so. 1 second is okay. We are losing some precision, but we are not hurting the motors or whatever we have. This highly depends on your actuator that you have. 1 second should be fine in our case. Yeah, good. Doesn't work anymore? Oh no, it still works. Some update thingy. So, good. Yeah, that's pretty much it. I did this video because there was a comment about it in one of the previous videos, and I was like, hey, this is actually pretty simple to answer, and it's an important topic, right? And you see this is a pretty neat PWM. If you want to play around with this tool here, I will put the download link in the description below. You can find it in our forum. This digital version of the tank is not available yet in the version that you have. We're just having the analog one, which is available. I explained that in a previous video. Do not forget to subscribe. Do not forget to check out the forum that we have set up. You see, this is actually growing a little bit. So we already have some content here, which is nice. I want this to become a community, right? So everyone can share the knowledge. I love it because we have grown so much. We're almost we're above 6,000 subscribers here on my channel. So there is a lot of people and a lot of questions, which I cannot answer all of them. I'm sorry. Still put them in the comments below. Put them here in this forum. There is lots of other people that will answer too. And I try to get as much time in my life for this as possible to get to all of them. But I'm sorry already. Whew, that's so much now, and I'm having so much fun. Yeah, if you want to download the software, don't forget to check out Factory Simulator, which already has 450 downloads. Pretty good. And the last thing, of course, do not forget to like, do not forget to subscribe, and if you've got a couple of dollars left in your wallet, as always, do not forget, I'll put the link in the description below, to check out my GoFundMe and throw some bucks to me. Thank you, Robert Wanglords, 30 euro. That's a lot of money. Thank you very much. Much appreciated. That's a lot of time that I can now invest in developing the software and my online material. Thank you. the least everyone can do, don't throw money at me if you don't want to, that's fine. But the least you can do is hit that like button, hit the subscribe button, and ring the bell, and watch my other videos, generate some watch time, generate some clicks, and I will see you in the next video. Stay healthy, stay safe. Bye-bye.